Hi, everybody. This is Mr. Folly, and welcome to podcast 8.3, where we're going to talk about energy diagrams with humps and energy diagrams with speeds. So let's go ahead and get started with that. Energy diagram. So an energy diagram is a graph of potential energy. We'll come back here. And time. Okay. So it starts off with a reactant and a hump, and then so reactant, a hump, and a product. So every reaction has an activation energy it must overcome. Okay? So remember, when you break bonds, you absorb energy. So that means breaking bonds are right here. When bonds form, you release energy. Okay, so I'm going to have to draw this again. Woo. And you release energy. I'm going to put circles on that one. All the way down here. Okay, so if you remember, here's your reactants, here's your products. Okay, so my energy of my reactants would be right here. So if this was 75, it'd be 75. If this was 25, it'd be 25. Okay, so if I have a slow reaction, see how it takes energy to overcome that barrier? A slow reaction would have a higher hill. Okay, so my reactants are here, my products are here. Oh, come on. Has a higher hill. My reactants are here, my products are here, and the barrier is bigger. Okay, so slower reactions have bigger humps. Okay, now what a catalyst does, we talked about how last time how a catalyst speeds up a reaction. A catalyst takes a different pathway that shortens it. So now instead of having to go all the way this far out of the way, I only have to go this far out of the way before I can get to the products. Okay, so again, my energy is potential energy. Remember we talked about potential energy is bond energy. And this is time, except for I misspelled time, for the reaction to go through. Okay. So speed of reaction is based on the size of the humps. Now just so you know, sometimes the reactants start here and the products go here. And if I had one that did this and went, this one is slower, because the difference between my reactants and my hump, top of my hump, this one is faster, that distance is shorter. Okay? Review. Know your humps and the parts of the humps. That's it. Woohoo! Bonus section now. If I have a reaction like this, my reactants turned into my products. This is exothermic, because heat is coming out of my reactants to get to my products. Okay? Also, if I have one right here, whoop, this is endothermic, because my reactants have to absorb energy to get up there. Okay? Oops, I don't want to go there yet. And this difference between the two is called delta H. Remember we talked about that a couple of times, a couple of labs? That's delta H. In this case, delta H is negative. In this case, delta H is positive. Enjoy that little bonus thing. I bet there's extra credit on that one or something, but we shall see. That's it. We're really done. Toodles.